Okay, in today's mini lecture, I am going to teach you how to set up and to calculate the average atomic mass of an atom based on its isotopes. So we talked about the protons, and we said that if you change the number of protons, then you change the element itself. So if you have magnesium, and magnesium has 12 protons, and I say, oh, I have magnesium with 6 protons. No, you don't. If you have 6 protons, you change that whole element, it becomes carbon. So the number of protons changes the element. The number of electrons changes the charge. If I have more electrons than I do protons, it's negative. If I have more or less electrons than I do protons, then it becomes positively charged. Well, in today's class, we're going to look at what happens when you vary the number of neutrons. Well, we already said neutrons are going to be those particles that are found in the nucleus that give the atom stability. So you start adding the neutrons to it and it makes it more stable. But there's not always just one specific mass that becomes stable. You can create other semi-stable, stable-ish type elements, and we call those isotopes. And isotopes is going to be any element that has a different atomic mass than what you would find on the periodic table. So let me show you this equation, or this question up here. It says, calculate the average atomic mass of 3 magnesium isotopes: magnesium 24, magnesium 25, and magnesium 26. It says their actual masses and percent abundances are, and percent abundance is how often it occurs. So this one, instead of it being exactly 24, we just rounded off for the 24 and we put 23.985. That's its actual mass. It occurs 78.70%. That means that if you were to take a sample, just random outside, dig it up, find magnesium, 78.7% of it would be this isotope. 10.13 would be the 24.986, and then 11.17 would be the 25.983. All right, so what I would like to do is show you how to set this up. Since each one of them is going to contribute a different amount, the way that I've always taught this is just simply use a table format. So I'm going to make headers, and I'm going to say the first one is the isotope itself. The second one is the mass of that isotope. The third one is the percent abundance. Then the fourth one is the mass contributed. So it's the mass contributed. So I'm going to look at my isotope, and this particular one I have 3. Now, do you see how I used the name of it and then I put a hyphen and 24? This is actually called the hyphenated expression, and it allows you to look at the overall atomic mass. So that number gives you the atomic mass. So I have magnesium. I'm just going to use its symbol, Mg-24, Mg-25, and Mg-26. So that's my 3 isotopes. Sometimes you have 2 isotopes, sometimes you have 3, sometimes you can have 4 or 5. So we go back in and we'll write down the respective masses. So this one is going to be 23.985. The next one is going to be 24.986. And then finally 25.983. Now I'm going to come back in and I'm going to write down the percentages. So the first one occurs 78.70%. Now guys, we know from our math classes that when you start dealing with percentages in math, you can't put a 78.7% into the calculator. So what you have to do is you have to take that out of the percentage and put it back in a decimal. So that's actually going to be written as its decimal form, 0.7870. This one is 10.13%. So again, 0.1013, and finally this one is 11.17%, and that's going to be 0.1117. So guys, I'm going to grab a calculator real quick so that I can figure these out while we're actually doing them so that we can get some actual numbers. So in order for me to figure out how much of this isotope's mass comes from this 24 isotope, I'm going to have to go through and say the mass of it, which is 23.985. I'm going to multiply that by the decimal percent abundance, which is 0.7870. And it comes out to be 18.88. I'm going to do the same thing with the next one, 24.986 times 0.1013. On this one, I get 2.53. And finally, let's do the last one, 25.983 times 0.1117, and I get 2.90. So guys, each one of these are contributing a certain amount of the overall mass. Well, a little bit of common sense would tell you that if 78% of the whole substance, the mass comes from this one, then it's going to contribute the most, and it did, 18.88. So if I wanted to see what its average atomic mass is, I've already done my division over here for the averages. I don't say add them all up and divide by because they have different percentages. So instead, after I figure out the masses contributed, this is the easy part. I know that my average is going to be whatever I get when I add these together. So I'm going to go through and say 18.88 plus 2.53 plus 2.90, and all of this, oh, I accidentally hit the wrong key. Let me try it again. 18.88 plus 2.53 plus 2.90, and that is going to give me a total of 24.31. And that is going to be the average atomic mass. And you see how I put it in a nice table format? Guys, if you do this, you can address and do any of these average atomic mass. Look how easy and how systematically this is laid out. So I do require you to actually show me this work. So you're going to have some work that I'm going to give you after this video where you have to go through and work out 5 of these problems. So you're going to do it on your own paper. You don't have to copy the questions. It's found in your digital notebook. You'll go through and you'll work them all the way out, and then I have another video that'll show you how to post your work onto your digital notebook. So in today's class, we went through and learned how to set up in table format and calculate the average atomic mass of an isotope. You also learned that if it is a dash in here, that is going to be called the hyphenated expression, and the number that comes after it would always give you the mass of that isotope. Now, since each one of these are magnesium, I know that magnesium on the periodic table, it's over here to my right, it says that magnesium has an atomic number of 12, so its number of protons and its atomic number stays the same because it stays the same element. All right, I hope you enjoyed that, and I'll see you in